So this is the flipbook of the simulation that we did in the last video. If we play the simulation now, the plane is interacting well with our water, but I think this doesn't happen in the way that we want. We need this plane to crash, and we need a lot of water to splash, like that something heavy hit this water. So although that we have a proper collision geometry, there is still something that we should do in order to get a proper collision, and this thing is just measuring the velocity of the plane and add it to our collision data in order for Houdini to calculate the collision well, and this will cause our plane to crash heavily because Houdini will take the velocity into consideration and will calculate the collision based on the velocity. So if your object is faster, or as long as your object is faster, you will have a more strong collision. Okay, so let me cancel this flipbook, and to add our velocity we just do a simple thing. Notice that we have moved to Houdini 18, and everything that I have discussed in the last videos, it's the same. They are all the same in Houdini 18 and Houdini 17.5, so it doesn't matter if you use Houdini 18 or Houdini 17.5. there is no difference, as we have at least at the things we have discussed in the last videos. For these two options here and this option, they are still the same and no change happened. Okay, so we are going to enter here. We need to add our velocity, so we will add a trail node, and in the result type I will change it into compute velocity. Okay, and velocity approximation, I'm going to make it central difference because this will compute velocity in a more accurate way than the backward difference. Okay, so this is the trail node where we will compute velocity, and this will be added into our plane collision, and Houdini will take it into consideration. Then here in this flip tank object, I will just decrease the particle separation in order to get some a relatively high number of particles, because I want my simulation to be in a higher resolution. So here we go. I'll change this into 0.3, and we'll discuss a lot about particle separation and resolution in the next video. But let me add a flipbook and then return to you. So here is my flipbook. If we see now, the collision is stronger, and it's not very good, and it's not like what we want. But when you will just lower this particle separation, the resolution of the simulation will be higher and the collision will be better. So now we're just doing the simulation with 100 with the 1 million particles. So when we just use a high particle separation and increase the number of particles into something like 20 million or something like that, your collision will be a lot better and the simulation will be more realistic. But now we have a proper scale and we have a good simulation, or a good base for the simulation that we want. So this is for this video. In the next video we will talk about a parameter in the flip tank here. This parameter is particle separation, and we will do several tests in order to test this parameter. Okay, so thank you, and wait for me in the next video.